Hello all, welcome to the day 61 of the daily case study series for CBSE grade 10. The question goes like this. Read the following text carefully and answer the questions that follow. An international school in Hyderabad organized an inter-school throwball tournament for girls just after the pre-board exam. The throwball team was very excited. The team captain Anju directed the team to assemble in the ground for practices. Only three girls, Arushi, Sarika and Avni, showed up. The rest did not come on the pretext of preparing for pre-board exam. Anju drew a circle of radius 5 meter on the ground. The center A was the position of Arushi. Anju marked a point N 13 meter away from the center A as shown her position. From the point N, she drew two tangential lines NS and NR and gave positions S and R to Sarika and Avni. Anju throws the ball to Arushi. Arushi throws it to Sarika. Sarika throws it to Anju. Anju throws it to Avni. Avni throws it to Arushi. Arushi throws it to Sarika, and so on. From the question, I have taken down the position of four people. N is where Anju stands. S is where Sarika stands. A is where Arushi stands. R is where Avni stands. Question 1. Find the measure of NSA. This angle NSA is formed at the point of contact of the tangent NS and the radius AS. Therefore, angle NSA is equal to 90 degree. Angle NSA is equal to 90 degree. The reason being radius is perpendicular to the tangent at the point of contact. Question 2. Find the distance between Sarika and Anju. The distance between Sarika and Anju is represented by the line segment SN. So let's consider this right angled triangle ANS. SN is equal to square root of AN square minus SA square. This is by Pythagoras theorem. SN is root of 13 square minus 5 square, which is root 144, that is 12 meter. Therefore, the distance between Sarika and Anju is 12 meters. Question 3. If angle SNR is equal to theta, SNR, that is this angle, then find angle NAS. NAS is a portion of the angle subtended at the center. Here, A is the center of the circle and N is one external point. The line segment which connects the center and the external point bisects the angle at N. So the angle SNA becomes theta by 2. Angle SNR is equal to theta. The line connecting center of the circle to an external point is at N, bisects the angle between the two tangents. Therefore, angle SNA is equal to theta upon 2. Let's consider this triangle SNA. In triangle SNA, angle NAS plus angle SNA plus angle NSA is 180 by the angle sum property of the triangle. Angle NAS plus SNA is theta upon 2 plus NSA is 90 degrees, which is equal to 180 degrees. So angle NAS is 180 minus 90, which gives 90 minus theta upon 2. R part of the third question, find angle SNR plus angle SAR. Let's consider the quadrilateral SNRA. The sum of all angles is equal to 360. Angle SNR plus angle SAR plus angle NSA plus angle NRA is equal to 360. NSA is 90 and NRA is also 90. Angle SNR plus angle SAR plus 90 plus 90 is 360. So angle SNR plus angle SAR is 360 minus 180, which is 180. If you found this video helpful, Don't forget to like, share, and subscribe to my channel, Math with Meenakshi, for more smart learning videos. See you all with another case study question tomorrow.